Okay, so let's talk about what you need to know when you are solving for equations in Chapter 3. The three ways to organize your thoughts is the what, the how, and the when. When working on these, you want to think of it as, for starters, what are we trying to do? When you solve an equation, your goal is to solve for some unknown, whether it be the number of DVDs you need to sell or just a value for your variable. So when you solve an equation, your goal should be to get your variable by itself. Because if you get your variable by itself on its side of the equal sign, the other side of the equal sign will have the value, will have the answer for what is that variable equal. So your goal when solving equations is always get your variable by itself. And I'll even include on its side of the equal sign. So now that's your what. The question that a lot of people have is the how. Like, how do you move things away? Because if you're getting the variable by itself, that means you're moving things away from the variable. When I say away, I mean to the other side of the equal sign. So let's see. If you have 2x equals 12, we've got to solve for our x right here. So if you're going to solve for x, you're going to move the 2 away from the x. You move the 2 away from the x by answering the question, how? When you have a coefficient touching your variable, that means multiply. How do we move things to the other side? We always do the opposite operation. The opposite operation is also known as the inverse operation. So the opposite of times 2 is divide by 2. I'll do that in a different color so you can see what I'm doing to both sides. So divide both sides by 2. That's how you get rid of a coefficient. And in fact, that's how you get rid of all coefficients. You always divide, whether the coefficient is a decimal, a fraction, or a number like it is here. So those cancel because times 2 and divided by 2, they undo each other, so why bother? So if let's say you were the number 3 and you multiplied by 2, you're now 6. But if you divide by 2, you're back at 3 where you started, and so you didn't go anywhere, so why bother? So those cancel out and you're left with just your x over there. Now on the right side, you just ask yourself, what is 12 divided by 2? 12 divided by 2, we all know is 6. So look what you have. You have your variable by itself, your variables by itself, and on the other side is the value of your variable. So you now know that x equals 6. So that's the how. That's what I mean by the how. And so let's see, that was a multiplying one. So when you divide, let's do a dividing one. So let's say x divided by 3 equals, I'll keep it simple, we'll make it 7. You see you have x divided by 3. So to get x by itself, you have to get rid of divided by 3. To get rid of divided by 3, we're going to do the opposite operation, which is multiply by 3. So you're going to multiply both sides. Because remember, our number one rule we talked about when we learned equations was you can do whatever you can do whatever you want to an equation as long as you do the same thing to both sides. So let's see, we have times 3 and divided by 3. Those undo each other for the same reason that the times 2 and divided by 2 in our last example did. So on the left side, we just have an x. But now on our right side, we have 7 times 3. And 7 times 3 is 21. And that is your answer for that equation. So let's see, that's multiplying, that's dividing. The only thing that might happen is if you have negatives inside of these problems, you want to keep track of the negative values using what you know about negative numbers. For example, if that had been a, let's do a what if in green, if that had been a negative 3 down there, we would have multiplied both sides by negative 3, and so our answer would have been negative 21, because positive 7 times negative 3 is negative 21. So if there's negatives involved, just keep track of your negative skills. Same thing if it's an adding or subtracting question. So as a reminder, if we had x plus 7 equals 2, this one will have a negative answer. We get x by itself by getting rid of plus 7. You get rid of plus 7 by doing the opposite operation, which is minus 7. So those cancel. On the left side, by the way, if you don't know if those cancel, think of it this way. Plus 7, that's like saying positive 7. Positive 7 minus 7 is 0. So so you actually have x plus 0, but when you add 0, it doesn't do anything, so don't bother. So just cancel them out. So you have x down here. So now, on the right side, 2 minus 7. On the number line, if you start on 2, you minus 7, you go left 7 spaces. If you go left 7 spaces, you end up on negative 5. So not only did that question require you to use your equation solving skills, but it also required you to use your negative skills that you learned back in chapter 1. Do not forget about those. Now let's see, we did a multiplying example, we did a dividing example, we did an adding example. If you have a question that has subtracting, such as x minus 3 equals, we'll say, negative 14. I'm just trying to use negatives to make sure we're also reviewing our negatives. You get x by itself by getting rid of minus 3. You get rid of minus 3 by doing the opposite, which is plus 3. So add 3 to both sides. The opposite of minus 3 is plus 3. You could also think of it as the opposite of negative 3 is positive 3. Negative and minus kind of mean the same thing in equations for whatever you need at that moment. So you can think of that as positive 3 or plus 3. So those are opposites and they cancel. On the left side you have just x. On the right side you have negative 14 plus 3. If on the number line you start at negative 14 and you add means go to the right. So from negative 14, go right 3 spaces on the number line, which means you're coming back towards 0. That's going to give you negative 11. So that's your answer for that one. Now, you can always plug these answers back in to check your answers. You can always plug them back in to check your answers. A lot of us get lazy with checking our answers when we have easy questions, or when we have one-step equations like these. We always sometimes get overconfident and we don't always do them in the order that we need to. So what I want you to think about at the same time is also what happens when there's more than one thing to do. Like, what if we had multiple things that we had to keep track of? So for example, let's talk about a when. So that's really the how. So we talked about the how. So let's separate that. Let's talk about when. What if you had more than one thing to do? In all 4 of those examples, we only had one thing to move. Those are one-step equations. So the when didn't matter. There was only one thing we had to do. But what if we have more than one thing to do? For example, what if we have, I'm just making this up off the top of my head, 2x minus 5, that is an ugly 5, 2x minus 5 equals 3. If you have that equation, your job is to still the original goal. Get your variable by itself. So if you look at your x, on the side of the equal sign with your x, over here, you've got 2 and minus 5. You've got times 2 and minus 5. So those are the 2 things that you have to move to the other side. So you have to decide which one do you move first. And yes, it does affect your answer, and it does affect whether you go to algebra jail or not, what order you move those in. So we always said in class, the when you always have to remember is the order of operations backwards. The when that you move things, the timing is the order of operations in reverse. That tells you what order to move them in. We talked about the how to move them in the how section, but the when is a little bit different. So let's see, the when. So we know we have multiply by 2, we have minus 5. In the order of operations, the one that comes last out of multiply and subtract, the one that comes last is subtract. So because that's last in the order of operations out of our choices being multiply or subtract, that's the first one we undo. So now ignore the rest of the question. Think of it just as, how do I undo minus 5? And we just did an example earlier where you get rid of minusing by adding. So we're going to add 5 to both sides of our equation. They cancel on the left side. So now on the left side, we're left with just 2x. I see there's nothing right here, so we're just going to bring down the equal sign. So now on the right side, we have 3 plus 5. 3 plus 5 gives us 8. So we have 2x equals 8. At this point in time, 2x equals 8, that is an equivalent equation to your original equation at the top, 2x minus 5 equals 3. You know it's equivalent because you use one of your properties of equality. That's a fancy way of saying you did the same thing to both sides. If you do the same thing to both sides, you are allowed to, because we said the number 1 rule is do whatever you want to an equation as long as you do the same thing to both sides. You technically are allowed to. I'm just helping you choose sometimes what are the best things to do to help you find the value of your variable with the least amount of steps. Okay, so let's see. At this point, we have 2x equals 5. That means 2 times x. I said 5, I meant 8. So that's 2 times x equals 8. So now our job is just to get rid of the times 2. You get rid of times multiplying by dividing. So divide both sides by 2. So these are the opposite operations, otherwise known as inverse operations. So those cancel. The x stays behind, so we still have an x. Now on the right side, we have 8 divided by 2. And those of you out there paying attention, you know 8 divided by 2, you know your times tables. I know that's a simple one. It's going to be 4. Even though you may still be able to do some of these in your head, I still want you to organize yourself and show your steps being what I did in red, so that you know what you did to both sides, and you know what cancels, and you know what you're left with. The skill of being able to simplify equations by moving things around without breaking any rules, you're going to need that skill not just for solving equations, but sometimes for rewriting equations or rewriting formulas if you're trying to figure out one unknown. So this is a skill you want to practice now, even when the questions appear to be easy. Okay, so that was us talking about a win. If you like, we'll do one more example where we'll include a fraction in there, since I know sometimes we can get confused with fractions. So here's what we'll do. We're going to make a question that's going to have both fractions in it, but this goal is going to be the same. Get x by itself. All right, so we have a question that is an equation where we've got 1/3 x plus 2/4 equals negative 1/3 x minus 1/4. So there's nothing but fractions in here, but our goal does not change. We are still going to get x by itself, and we're going to do that by first combining our x's. So we'll get to that. So we've learned in class that when you have variables on both sides, you always want to start by combining your variables. So in this example, I wanted to do an advanced example to where you're still seeing the win, but you're seeing what happens if you have a variable on both sides. So this example is coming from section 3-3 part D, solving with variables on both sides. But it's going to be a problem where we have variables on both sides, but we also have all fractions. So our goal is going to be this. When you have variables on both sides, the first thing you always want to do is move all your variables all to one side. You do not have to do this, but it is highly recommended. So we're going to move all of our variables to one side first. When you do this, if you want to avoid a negative variable, which may sometimes give you an extra step at the end, if you want to avoid that, you should always move the smaller variable towards the bigger variable. So let's see, in our example, we have positive 1/3 x and we have negative 1/3 x. The bigger one is going to be the positive 1/3 x, which means we're moving negative 1/3 x. In order to move the entire thing, the negative 1/3 x, we ask ourselves, what's the opposite of negative 1/3 x? And so the opposite is going to be positive 1/3 x. When you think positive, think plus. You can think of that negative sign as a minus sign if you need to. So you're going to show your work by, you're going to add 1/3 x to both sides. Now, if this is confusing you what to do with variables on both sides, for now, just trust this step, ignore it, but watch what happens as soon as you do this. You're going to have a two-step equation. And so you're going to have one just like the one we just did, but with fractions in it. Okay, so like I said, if you're still having trouble with the variables on both sides, put that on hold for now, but just think about what is our overall goal. So we're going to combine our x's first, so that it's a two-step equation to where we can go back to our overall goal, which is get x by itself. Okay, so let's see. Those cancel out on the right side because they're opposite of each other. On the right side, we still have that minus 1/4. That minus 1/4 can also be thought of as negative 1/4. You're physically just bringing down what's not crossed out. Technically, it's negative because the negative 1/3 x plus 1/3 x technically equals 0. So technically, that means 0 minus 1/4, which is negative 1/4. But you don't necessarily need to go through those steps. You can just bring it down. That's fine. Okay, so now on the left side, let's see. I see a plus 2/4. I'm going to leave it as 2/4. That just drops straight down. But now we have positive 1/3 x plus 1/3 x. So let's see. When you add variables, you add their coefficients. So if we add those coefficients together, 1/3 plus 1/3, that gives us 2/3. And the x comes along for the ride. He's your way of knowing they are like terms. They both have x's, so you just add the coefficients. So far we've got 2/3 x plus 2/4 equals negative 1/4. We now have an equivalent equation to the original. There are many equivalent equations to any equation. we know that we just have 1 because we did the same thing to both sides. So now, if you got stuck on the issue of combining your x's, remember what I said. You do not have to combine your x's right away. I just suggest it because I'm getting you ready to do things with a priority level that helps you solve it with the least amount of steps. You technically could have done whatever you wanted to both sides, but I like to combine my x's first. Think the mutant chicken method we talked about in class. I don't like chasing 2 chickens, so I combine them right away, so I only have to chase 1 chicken. All right, so let's see. Now we're going to get x by itself. I see 2/3 times x, and I see plus 2/4 on the left side with the x. So our goal is to get everything away from the x. So to get those things away from the x, we're going to have to do order of operations in reverse. That's our win. So let's see. We have multiplying and adding. Just like over here, we know that adding is going to come in the order of operations after multiplying. So because of that, it's the first thing we move. So we're going to move plus 2/4. The opposite operation of plus 2/4 is minus 2/4. So we're going to subtract 2/4 from both sides. Once we do that, they're going to cancel on the left. So now on the left side, we're going to have 2/3 times x all by itself. Drop down your equal sign. Now on the right side, negative 1/4 minus 2/4. This is where you use both your fraction skills, and in this case, you're also using your negative skills. Fraction skills tell us if we add or subtract fractions, we must have common denominators. In this case, we do. The denominator for both of them is a 4. Okay, so that's taken care of. So know the denominator down here is going to be a 4. So now you got to use your negative skills. You got negative 1 minus 2 on our number line. If you go to negative 1 and you minus, you go left. So that means you're going deeper into the negatives. So negative 1 minus 2 gives you negative 3. So you got a negative 3 up top. So you have negative 3 over 4. It does not matter if that negative's up top or on the side, by the way, as long as there's at least one negative sign. Okay, so let's see. We're left with 2/3 x equals negative 3 over 4. That means 2/3 times x equals negative 3 over 4. So now your job is you have one more step to get rid of. Just like we learned earlier about the how to get rid of all coefficients. Remember, you get rid of all coefficients by dividing by that coefficient. So let's see. We have times 2/3. So we're going to get rid of that by dividing by 2/3. You divide by what you're moving. So divide both sides by 2/3. So they cancel over here. And so on the left side, you're left with just x. Now, on the right side, you've got to now use your fraction skills. The goal is the same though. We move it to the other side with division. Now here comes the detail. The detail is remembering what you learned in chapter 2, how to divide by fractions. So let's see. Some of you remember it as keep, change, flip, which is a little way to remember it. Some of you remember it as just remembering how to divide by a fraction. You know when you divide by a fraction, you multiply by that fraction's reciprocal. No matter what way you think of it, you write it like this. Negative 3 over 4 stays negative 3 over 4. That division becomes multiply. So you now have multiply. So now, but when I said reciprocal, that means flip it. So that whole keep, change, flip, this is the flip part. That 2 over 3 becomes 3 over 2. So you have negative 3/4 times 3 over 2, 3 halves. Once you figure out what this equals, that will be the answer to your question once you simplify it all the way. So I'm out of room down here, so I'm just going to move it over real fast. I'm going to move over up there. I'm going to rewrite what we have so we see I just transferred it. So let's see. We've got x equals negative 3 over 4 times 3 over 2. Okay, so now our fraction skills, when you multiply fractions, you multiply straight across. So we're going to multiply straight across. So that gives us x equals, up top, we have 3 times 3 is 9. Now on the bottom, 4 times 2 is 8. That negative number, don't let him be a headache. When you multiply and divide, worry about him afterwards. Here's what you ask yourself. I have a negative number times a positive number. So you're using your chapter 1 skills with integers. Negative times a positive is a negative, so you've got negative 9 over 8. So you have x equals negative 9 over 8. Your last job is just to simplify that fraction, that improper fraction, into a mixed number. So we're going to simplify that. 8 goes into 9 one time with a remainder of 1. So the 1 time is the big number, the remainder of 1 is on top. It is still going to be negative. So our final answer is x equals negative 1 and 1/8. So now, this question may have looked really hard, but it looked hard mostly because of the fractions all inside of it. But what I want you to realize is our goal was the same. Get x by itself, and then you have your answer. In this example, though, we had more than one x. And so I reminded you what to do when you have an x or a variable, whatever it may be, on both sides. Move it to one side by always moving towards the larger variable. And then you've got a two-step equation where we had 2/3 x plus 2/4 equals -1/4. That was an equivalent equation, but it was a two-step equation that's much more attainable than when we have two chickens running around our farm at the same time. It's not fun chasing two at the same time. So let's recap with the what, the how, and the when. The what was solving equations. You do that by getting your variable by itself on its side of the equal sign. Move everything away. The how do you move things? Because the what is get by itself, so move everything away from the variable. And now the how is move those items by doing the inverse operation to both sides. Do not forget, inverse operation is a fancy way of saying the opposite operation. The opposite of multiplying up here was dividing. The opposite of dividing is multiplying. The opposite of adding over here is subtracting. The opposite of subtracting over here is adding. So if you know the how to move things, you now have the tools in your toolbox. What's going to happen with multi-step equations, such as two-step equations right here, you're going to realize there's more than one thing to move. So you need to ask yourself the when. The when you keep track of is the order of operations in reverse. You undo everything by doing the order of operations in reverse. So I see times 2 and minus 5. Minus 5 comes last in the order of operations. Therefore, it's the first thing you undo. You undo minus 5 by adding 5. And then you got to undo the multiplying the coefficient, because 2 times 2x means 2 times x. You undo that by dividing. So essentially, that is the big idea of the 3 things you want to focus on with chapter 3. So come to class with specific questions if there's certain steps you don't understand, but make sure you're keeping track of the big ideas, the what, the how, and the when. I hope this helped.